solving x squared plus bx plus c equals 0 by factoring. Okay, so we're going to solve by factoring. I know you factored before in algebra. Sorry. I know you factored before in algebra, so let's talk about this. If you have x squared minus 9x plus 20, do you remember how to factor that? Okay.
I honestly don't remember
make it
factoring it.
x minus, no, x plus 3 and then x minus 2.
Kind of. You're on the right idea. But let's talk about this. You're going to have two sets of parentheses, yes? Because this is a leading coefficient of 1, I just put an x in both. And then I have to say this to myself. What multiplies to give me 20, but will add to give me negative 9?
Oh, 5. Well,
Yeah, that
Yeah.
works.
yes.
Say, what did you say?
Negative 5 and negative 4.
Yeah, negative 5 and negative 4. Now, another way to do it is to take 20 to the side and list all the factors of 20 so that you can see.
That's the way I always taught it.
You can do it that way if you want to. When we get into leading coefficients that are not 1, you'll want to do it that way. Because we're going to have to take into factor what's outside of here besides 1. But when I'm factoring, that's what it is. So when it says factor, that's what you're giving me. If it says solve, then I have to set both of these parentheses equal to 0 and solve for x. Okay, so when it says factor, I leave it this way. This is factoring. Okay, what multiplies to give me positive 20 and adds to give me negative 9. A negative 5 and a negative 4 is a positive 20. See, if I factor this out, if I FOIL it, I'm going to end up getting this answer back. That's how you can check your answer if you feel like you're wrong, okay? So you end up getting x squared minus 9x plus 20. You see how that works? That's how you can always check your answer, okay?
Do you want us to do that?
I would suggest that if you're uncomfortable with it, like if you know for sure this is the right answer, you can leave it. But if you're uncomfortable with it, double check it, okay? It's always a way to make sure you're right. Okay, try this one. Just factor this. Let's say x squared, we're only going to do leading coefficients of 1, plus 3x minus 12. Okay, so I set up my two sets of parentheses, yeah? I put an x and an x. And what do I ask myself?
What two numbers that add up 3 that are multiplied to 12?
Yes, what two numbers multiply to give me negative 12, but add to give me positive 3? What two numbers multiply to give me negative 12, but add to give me positive 3? So look, here's 12, right? My factors of 12 are 1 and 12, 2 and 6, 3 and 4. Can any of these add to give me positive 3? No, like even if I did 4 minus 3, that's not a positive 3. Or 6 minus 2, that's not a positive 3. So this one is not factorable. That can be an answer, okay? Something cannot be factorable. Don't get like tricked up by that, okay? If you list everything, your answer could be not factorable. Okay, there are two special types that we're going to talk about of factoring, and they're patterns that you just have to memorize. And if you memorize them, you don't have to do any work. You don't have to ask yourself, what multiplies to give me this and adds to give me that. You literally just see the pattern and you can fill in the answers. Okay? So the two patterns are called difference of two squares and a perfect square trinomial. A difference of two squares looks like this. So, in a difference of two squares, the middle is missing. So if I use numbers, it would be something like x squared minus 4, okay? It tells you exactly what it is. Difference of two squares, different sign. This is a perfect square, this is a perfect square. So if the middle is missing, if the x is missing in the middle, check and see if these are perfect squares. If they are, it's a difference of squares, and this is how it factors out. X plus 2, x minus 2. Because 2 times negative 2 is negative 4. You take the square root. And x times x is x squared. So when you see a difference of squares, it should be super easy. You don't have to do any work. You just have to know what the square root of this number is. Which, if it's a large number, we can put in our calculator and check. Okay? Now, the other one is called a perfect square trinomial. And like I said, we'll work on this more tomorrow too. But perfect square trinomial is like this.
Lucy,
I
you
have-
on the quiz?
Yep. Okay. Here's how you recognize a perfect square trinomial. This has 3 things, hence trinomial. Okay? It has all 3 sections. You're going to check to see if the first number is a perfect square. Okay? Is x squared a perfect square? Yes. Is the last number a perfect square?
Yes.
Yes. Does 3 plus 3 give you 6?
Yes.
So when you factor it, you say x plus 3 squared.
That's all you have to do.
That's all you have to do. Whatever this sign is what goes in here. So if I had x squared
Wow.
minus 4x, okay, plus 4, okay. Is this a perfect square?
Yes.
Is this a perfect square?
Yes.
The square root of 4 is 2. Can 2 and 2 get me negative 4?
Yes.
Yes, because they both would be negative. So the negative sign, the sign here and here depends on what the sign is here and here. Okay? So those are 2 easy ones. You just have to start to be able to recognize them. Okay? So let's look at,
This isn't a graphing lesson.
not a graphing lesson. Let's look at this one. Tell me. How can I factor x squared minus 9?
X
Plus
minus
3.
Good. X plus 3, x minus 3. How can you factor y squared plus 16y plus 64?
Oh, y plus 8 squared.
Beautiful. Y plus 8 squared. Okay. What about q squared minus 100? Is that a perfect, is that a difference of squares?
Yes.
Yes. What is it then?
Q plus 10, Q minus 10.
Okay. Do you see how those 2 like sheets help us a lot? We don't have to sit there and factor anything. Makes it beautiful. So if the middle is missing and there is a minus sign, that is your clue to check to see if these are perfect squares. If you have a trinomial, anytime you have a trinomial, check and see if the first is a perfect square. Check and see if the last is a perfect square before you factor. Okay, it might save you time. If they are, hey, look at that. Okay. So that is when it says factor. When something says, what are the zeros, or if something is set equal to 0. Okay. When it says solve, when it says, what are the zeros, or when something says, or when it is set equal to 0. They want answers. They want you to factor and give answers. So this is factoring, okay? If I have an equation that says x squared minus 5x minus 36 equals 0, that means I am solving for x. But to solve for x, you first have to factor, okay? So let's take a look. Is this a perfect square trinomial? That's a perfect square, right? That's a perfect square, but does 6 and 6 get me to 5 anyway? No. Okay. So we have to factor this. X. Okay. So I asked myself, here's 36. What are factors of 36? What multiplies to give me 36 but adds to give me 5? 36 is 1 and 36. 2 and 18, right? 3 and 12. Does 4 go into 36?
Yes.
8 times? 9 times, thank you. 5 doesn't, and 6 does, yes? Okay. So what can multiply to give me 36 but add to give me negative 5? 4 and 9? Negative 9 and 4, good. Negative 9, positive 4. Now, I am not done because it is set equal to 0. The next step you do is you take each of these equations and you set them equal to 0, each of what you factored out. Okay? And you solve for x from there. So I add 9 to both sides. I get x equals 9, or I subtract 4 from both sides, and I get x equals negative 4. These are my solutions. Okay? Right now, they're not having us plug them back in and check which ones are correct. They just want you to solve for x. Okay? So, when it says factor, you leave it like this. Okay? When it says solve, what are the zeros? Or when it is set equal to 0, you have to give me what x is. I'm going to give you some more. Let's try. I know you're thrilled. Let's try. Y
I feel like
squared.
these are more like kind of riddle things. Like it feels kind of like a riddle. Like you have to find out what fits.
Yep. It's like it's a guessing game a little bit. Okay, what are the zeros? Y equals. We're going to do x squared minus x minus 12. Okay, what do I need to do first?
You need to factor.
You need to factor. Okay, so let's factor. How do I factor? I would write a table. 1 and 12, 2 and 6, 3 and 4. What multiplies to give me negative 12 but will add to give me negative 1?
Positive 3, negative 4.
Beautiful. Positive 3, negative 4. Because negative 4 plus 3 gives me negative 1. 3 times negative 4 gives me negative 12. Am I done? What do I have to do now?
No, you're not. You have to set them equal to 0.
Okay, x plus 3 equals 0. X minus 4 equals 0. Subtract 3, x equals negative 3, or add 4, and x equals 4.
Now, when we set it to 0, do you want to see us do the work, or do you matter for something?
Well, I want you to get in the habit of doing the work because later on we're going to have something else out here with the x, so it's going to be a multiple step. Okay? So let's get in the habit of doing that for me. Let's try one more, okay? Let's try, what are the zeros of y equals x squared plus 12x plus 36? Y equals x squared plus 12x plus 36. What do I need to do? First of all,
Perfect square.
it's what?
It's 6
Perfect square.
It's a perfect square trinomial. Okay, this is a perfect square. This is a perfect square. 6 and 6 can get me to 12. Beautiful. So that means that when I factor it, I get what?
X plus 6 squared.
Okay, now I have to take that and set it equal to 0.
Both times.
Right, or I can do it this way. Yes, it's very easy. Okay, how do you get rid of a square? Yeah. Take the square root. What's the square root of 0? 0. So x equals, boom. Okay, you were working on this today. That's why I said tomorrow we'll work on the same 3 lessons still, tie them all together, and review before your quiz on Friday. Okay?